Throughout this section, you learned a lot about routing. You know how to set up routes, to load them both through route link or programmatically, how to pass params, query params, how to use the data, how to load different components, and much more. One important feature is left in this module, which I definitely want to cover: route guards. So basically, functionality, logic, code, which is executed before a route is loaded or once you want to leave a route. Let's start with a simple use case. Let's say you only want to give access to your server component, your single server component, or the added server component if a user is logged in. Now, we're not going to add a full login functionality. For this, we will later have the authentication section in this course, but we will fake it for now. Still, we want to check this before any of our sub-routes here, so servers 3, servers 1, and then also the added routes are accessed. Now, manually checking this in the onInit function of our server and added server component would be very cumbersome, because you would have to add it in both components, and if you add more components belonging to the server's feature, you would have to add this over and over again. So therefore, we want to use a feature built into the Angular router running some code before a component is loaded. We will use the can activate guard, and we will do so in the next lecture. As mentioned in the last lecture, we want to maybe protect some of our routes. And we can use a feature offered by Angular which allows us to run some code at a point of time defined by us. I will add a new file in our root folder, and I will name it auth-guard.service.ts, because the code we run there is stored in such a service. I'll name it auth-guard though, because the feature of the Angular router is called guards. It guards certain actions like navigating to, around, or away from it. But in the end, it is a normal service, and therefore, as such, I will export a class which I'll name auth-guard. Now, you could add service here to be fully in line with all the other services, but since we will only use this as a guard, I will leave it at the auth-guard name. And now here, I will implement the can activate interface. This interface is provided by the Angular router package, so you need to import it, and it forces you to have a can activate method in this class. The can activate method now will receive two arguments: the activated route snapshot and the state of the router, so the router state snapshot. So make sure to also add these imports at the top here from @AngularRouter, and to add them here as types for the two parameters we get in can activate. Now you might ask, where are we getting these arguments from? Keep in mind, we will soon define that Angular should execute this code before a route is loaded, so it will give us this data, and we simply need to be able to handle the data. So that is can activate with the arguments it requires. Can activate also returns something. It either returns an observable, so make sure to import observable from RxJS. Observable is the correct path in this case. This observable then will wrap a boolean, so it will in the end resolve to a true or false value. Alternatively, this route returns a promise, also returning a boolean in the end, or it returns just a boolean. So can activate can run both asynchronously, returning an observable or a promise, or synchronously, because you might have some guards which execute some code which runs completely on the client, therefore it runs synchronously, or you might have some code which takes a couple of seconds to finish because you use a timeout in there, or you reach out to a server, so it runs asynchronously. And both is possible with can activate. You will see an example in a second. So here we want to be able to log in or out. For this, let's say we have another service, the auth service. And this is just a fake service here. So I will name it auth service. And in a real application, this might reach out to a server and allow us to log in or log out and check our current authentication state. I will track the state here too with the logged in property, which is set to false initially. And then I'll add a login method, which will set logged in to true, just like this, and a logout method, which will set logged in to false, to again fake this behavior. And I will have a method which allows us to check the state, authenticated, and here I want to simulate that this takes some time to finish, because maybe we reach out to a server. Therefore here, I will return a promise, a new promise therefore. This promise will, as always, take a method, a function as an argument with the resolve and reject methods we can execute. And in this promise, here I will execute set timeout to wait, let's say 800 milliseconds, and then execute another method in which I will resolve the promise and return this logged in. Again, just to fake that this takes a couple of seconds to finish, or some time to finish. So, with this auth service added, I now want to use it in my auth guard. And as this is also just a service, we need to add injectable to be able to reach out to the other service to inject that service into this guard. So make sure to import add injectable from Angular core. And then I will add a constructor to my auth guard where I reach out to my fake auth service here, of type auth service, therefore make sure to add this import too. And now in the can activate guard, I simply want to check whether the user is logged in or not. So here, I can reach out to my auth service to the isAuthenticated method, which again, keep in mind, returns a promise. Well, therefore we should return this promise here, I guess. So it returns us this promise. And here, I then want to be able to handle that whenever this promise in the auth service resolves. I know that there I will get back a boolean, so this authentication state, this logged in boolean is what we resolve here in the end, and this could be false or true. So I know that I will get back a boolean, and here I then want to check if this is true, in which case I want to return true, and otherwise I want to navigate away, because I don't want to allow the user access to the route he wanted to go to originally. I will navigate away to force the user to go somewhere else. So I will inject the Angular router for this, because this is how we can navigate with the navigate method. Make sure to add the import from @Angular router. And then here we can navigate with the navigate method. And let's say we just want to go back to our root page with just /. So in this case, our can activate method will navigate away. And I will now simply return this promise it still is in the end, because if we return something inside of the promise, it will give us back another promise. So now we're returning a promise here, which gives us back true, or simply navigates us away, canceling the old navigation anyways, therefore. So this now allows us to control access to whatever is controlled by this can activate guard here. Now we're still not using this guard, of course. So to use it, I'll go to my app routing module, and now we want to define which route or routes should be protected by this guard. And we do so by going to that route, it's the server's route and all its child routes, and adding can activate this property to it. Now can activate takes an array of all the code, basically, all the guards you want to apply to this route, and it will automatically get applied to all the child routes. So here, can activate will use my auth guard. Make sure to add the import here, pointing to your file. And this will make sure that servers is now only accessible, and all the child routes, only accessible if the auth guard can activate method returns true in the end, which will only happen if in the auth service logged in is set to true. Since this is set to false, and right now we never call login, this should always deny us access. Now before trying this, we need to go to our app module and add to the two new services we added. So add the auth service and the auth guard, which also is a service. Otherwise, Angular won't be able to inject them for us. So with that set up, Let's go to our application, click on servers, and I can click there as often as I want. I can't reach it. Users works, but servers always navigates us back to home after these 800 milliseconds, because that is how long it takes to resolve the information whether we are authenticated or not. We defined these 800 seconds here. So our guard is working, however, on our whole servers tab. Now I want to be able to see the list of servers and only protect the child routes. How can we do this? In the last lecture, we added the can activate guard, and it was working fine, but it was working for our whole servers path here. Now we could grab it from here and add it to our childs to make sure that only the childs are protected, the children, and not our root path. But that is not the easiest way, because if we add more child items, we have to add can activate to each of them. There is another guard we can use. It's pretty similar to can activate. It's called can activate child. So let's implement this interface too. You need to import it from @AngularRouter. And this interface requires you to provide a can activate child method in this class, which basically takes the same form as the can activate method. So it has the route and state, and it returns an observable promise or boolean. So this is the form of can activate child. Well, and since this is exactly the same form and we want to run the same logic, we can simply call, or return this can activate. So the other method we already included, and here we simply pass our route and state as arguments, since can activate expects these two arguments. What is the advantage of adding this then? Well, since we added the can activate child interface, we can now use a different hook here in our routes. Instead of only using can activate, we can use a different one, and I will split this over multiple lines to make it really clear on what's happening. I will comment out can activate and instead add can activate child. This now also takes an array of services which act as guards, which implement the right interfaces. And here we can still add the off guard, because the off guard now is able to do both. Protect a single route, since we have can activate implemented, or all child routes, since we have can activate child implemented too. So with this in place, we should now be able to go to servers. This works. But if we try to load a single server, now we get redirected back, because now only the child routes are protected, something I can also prove by trying to go to /1edit. This also navigates us back. So now this is the fine-grained control you can implement to protect a whole route and all its child routes, or just the child routes, depending on which behavior you need in your app. Now let's finish this can activate behavior by allowing the user to log in. I'll quickly do this by going to my home component, and there I want to add two new buttons, one login button and one logout button. And I will add some CSS classes, button default maybe, and button default here too. And here I want to execute on logout, and for the other one, of course, I will execute on login. And I will keep this really simple, since it's not about having a nice UI here. I will simply inject my auth service here, of type auth service, of course. Make sure to add the import at the top. And then I'll add my two methods here. So on login, we'll simply reach out to the auth service and call the login method to set this logged in boolean to true. And on logout, we'll of course do the same, but we'll call the logout method to set it to false. And this simple improvement now makes sure that we can of course log in. We don't see any visual indication here, but we do see it if we try to access a single server. Now this is working always after these 800 milliseconds, which it takes to evaluate whether we are allowed to access. But if I switch this back to log out again, you see we're redirected again. So now we can control this. Now we finish this fake off service, and more importantly, the can activate guards. In the last lectures, we learned how to use can activate to control access to a route. Now I want to focus on the control of whether you are allowed to leave a route or not. We can control this too, and we might want to control this if we are logged in once we do edit a server. Now we, for example, are allowed to edit the dev server, and here, if we actually changed something, I want to ask the user if he accidentally clicks back or somewhere else, if you really want to leave, or if you maybe forgot to click update server first. So this convenience method of keeping the user from accidentally navigating away. How can we implement this? Let's go to the edit server component for this, here, and let's add a new property. Below allow edit, I'll add a changes saved property, which is false by default, and which I want to change whenever we click on update server. Here, of course, we did update the server, so I want to call changes saved and set this to true here, because now the changes were indeed saved. After the changes were saved here, I want to navigate away. So I will inject the router here of type router, make sure to add the import at the top as always from the @Angular router package. And then here, after we saved our changes, I want to navigate away. I want to go up one level to the last loaded server. And for this, I will pass the relative to configuration and want to navigate relative to the currently active route. So far, so good. We're changing this changes saved property here. Now let's make sure that whenever the user tries to accidentally navigate away, that we prevent him from doing so, or at least ask if he really wants to leave. Now we somehow need to execute this code in this component here, because we will need access to this changes saved method, which informs us on whether this update button was clicked or not. However, a guard always needs to be a service, because we need to provide it just like we provided the off guard. So somehow this doesn't fit. We need to access the code in our component and have a service, and that sounds like a complicated setup, but it isn't. It's actually really simple. In my added server folder here, I'll add a new file. I'll name it can deactivate guard, and this again will also be a service, as all guards are. And in here, I first of all now want to export an interface. An interface simply is a contract which can be imported by some other class, let's say, which forces this class to provide some logic. So here I will name this can component deactivate, and this interface will require one thing from the component which implements it. This component should have a can deactivate method. This method, and this is simply how I define the type of this can deactivate method, since this is only an interface, it won't contain the actual logic, it will only contain the information how it should look like. So this method should take no arguments, but in the end it should return an observable, which therefore needs to be imported in this file here from rxjs observable, which will resolve to a boolean in the end, or a promise, which will resolve to a boolean in the end, or just a boolean. You might recognize this pattern here from the can activate guard. These guards share the same structure. So that is my interface. Nice to have it, but that alone won't do the trick. Now let's come to the important thing, the meat of this class, of the service here I should say, the service itself. So I'll name it can deactivate guard, and this guard will implement can deactivate. This is an interface provided by the Angular router, so we need to import it from there. This actually is a generic type, and it will wrap our own interface. So it will wrap an interface which forces some component or some class to implement the can deactivate method. Might sound complicated, but this is the setup which will make sure that we later can easily connect a component to our can deactivate guard here. So for now, let's just go with that piece of information. And now this class here, this guard, will also need to have a can deactivate method. This is the can deactivate method which will be called by the Angular router once we try to leave a route. Therefore, this will have the component on which we're currently on as an argument, and this component needs to be of type can component deactivate, which means it needs to be a component which has this interface here implemented, therefore a component which has a can deactivate method. This will become super important in a second. We also will receive the current route as an argument, so that is an activated route snapshot. Need to make sure to import this too. It will have the current state, so that is a router state snapshot, import this too. And the next state, so where do you want to go? Because remember, this will be called at the end when we want to leave a route. So next state is an optional argument though. This will also be a router state snapshot. And this will now also return an observable, a promise, or a boolean. So just like the can activate guard. That is how the can deactivate method in our can deactivate guard looks like. And here I now want to call can deactivate on the component we're currently on. And this is why I need to implement this interface in this component, why I created this interface in the first place, because now the Angular router can execute can deactivate in our service and can rely on the fact that the component we're currently on has the can deactivate method too, because this is where we will actually implement the logic checking whether we are allowed to leave or not, because we need this connection between our guard and the component. So this is why we can safely call can deactivate here. And now with that information, we can go back to our app routing module. And on the edit page here, we want to add this guard. So we can add can deactivate as a property to this route config. It takes an array just like can activate. And here we now will point to our can deactivate guard. Make sure to add this import therefore. And now Angular will run this guard whenever we try to leave this path here, this component loaded at this path. For this to work, we of course need to go to our module and provide our can deactivate guard, just like before, can deactivate. With this provided, make sure to add the import. We're almost there, but one important piece is missing. Remember that I told you that the can deactivate guard will in the end call can deactivate in our component? Well, for this to work on our added server component, here we need to implement our can component deactivate interface, our own interface we exported in our can deactivate guard service file, this interface. This interface now forces us to implement the can deactivate method in our component, which is important because we try to call this method on our component here. So in the added server component here, I will simply add a can deactivate method now. We know how this method should look like because we defined it here. It should return an observable, a promise, or a boolean. So let's make sure that it does. And now here, first of all, we need to import observable from rxjs/observable. But with that added, with this import added, here in can deactivate, we now provide the actual logic deciding on whether we are allowed to leave or not. This logic will be run whenever the can deactivate guard is checked by the Angular router. So here I will quickly check if we're first of all allowed to edit this, because if we're not allowed like this, here I will return true anyways, because hey, we weren't allowed to edit it in the first place, so sure, you may leave. And otherwise, I will check if my server name here is unlike the server name we had at the beginning. Server name here, this property, is simply bound via two-way binding to user inputs. So initially it is set to the value we get from outside, from the server which was loaded. We bind it here. But as soon as we type, we will have some differences. So if we have differences on the server name or on the server status, so here I also check if this is not the same as before, server status. So if one of the two was changed, and now I will wrap it in parentheses. So if one of the two was changed and the changes were not saved, so changes saved is false. In this case, I want to return a confirm dialog where I ask the user, do you want to discard the changes? Otherwise, I will return true, because otherwise either nothing was changed or it was changed, but changes saved is set to true, so we did save it indeed. With this in place, let's go back to our servers and first of all log in maybe. Let's go to the dev server, which is the one we are allowed to edit. And here, if I now type something there and I didn't click update server and I click somewhere else, we are asked if we want to leave. And if I click cancel, we stay on this page. We may now save our changes and then we are navigated away without getting any issues at all. And the fact that we updated the wrong server simply happens because here we still are always loading the server with the ID 1. So we should update this to get our real ID. So maybe here, access our route, snapshot, params ID, and pass this as an ID. And thereafter, of course, also subscribe to route params to update the ID if params change. That is something you can do as an exercise. And of course, make this of type number by converting it. But more importantly here, everything's working as it should. We are only allowed to change this if we did click update, otherwise we are asked. Or of course, if here once we are asked, we click OK, we are allowed to discard our changes. So that is true, or that is possible too. But now with can deactivate, we have this extra protection in place. So with this, we learned a lot about routing in this module. Now there's one more guard I want to dive into, and we will do so in the next lecture. Thus far, we had a look at two route guards. At the can activate guard and its neighbor, the can activate child guard, and at the can deactivate guard. Later in this course, in the modules section where you learn more about the Angular module, we will have a look at other routing related questions and also at guards again, but I'll come back to this. In this module here, there are still two other things I want to have a look at. And the first one is how to get some data, either static data or dynamic data once a route is loaded. Now you might correctly say, hey, we learned how to get data, how to get a parameter out of the URL and then use that. But that's not what I mean. I mean that some of your routes depend on data they receive either statically each time they are loaded, or they will resolve dynamically. Maybe I show some examples to make this clearer. Let's start with static data. We get our page not found component here. Now let's say we don't want to use that, but instead I will create a new component, the error page component. So this will be a generic error page, where the page not found component is pretty much limited to, well, 404 not found errors. We could imagine that we reuse the error page for all kinds of errors. So I'll remove the spec.ts file. And here in the template now, I don't want to output page not found or anything like this. Instead here, let's say we have some error message, which I want to output via string interpolation. The issue, of course, is this property doesn't exist as of now. So let's add it here. Let's add error message to this component. And we know it should be a string, but still, what would be the message? Because again, we might reuse this page. Now, for routing, there only is one proper use case you want to target right now, and that is that a route is not found. So in our route setup here, our redirect route here, which redirects to not found, which loads the page not found component here in the end. Here, I will duplicate this and then comment it out so that I have the code stored. Here, I now want to use the brand new error page component. So this error page component, which was generated by the CLI and for which you should add an import here. Of course, you should have also added this to your main app module if the CLI didn't do this automatically for you here and the import too. So with this, we're now loading this not found page, or excuse me, this error page if we target the not found route. Still, the issue is that here we try to output some message which we haven't gotten here. Now, we could reach this page through different hooks or for different errors, but for each error, there is only one message. So in our app routing module, we know that if we have the not found route and therefore a not found error, we will always display the same error message. And we can pass such static data with the data property here. The data property allows us to pass an object here. And in this object, we can define any key value pairs, any properties we want. Like, for example, our message, which is page not found. Now again, you might say, if I define it statically here and we will soon fetch it in the error page, why don't I define it there to begin with? Because we might reuse this error page. Maybe we got another route reaching this where we want to display a different error, or we have a different logic in our application which might render this page. So again, it might be reusable, but for each use case, there is a specific data field, a specific message we want to pass, like the page not found message here. So with this, we now want to retrieve that whenever we load our error page component. And for this, like params, like query params, we need the active route. So let's inject our activated route here, make sure to import it. And an ng on init, I can then again either assign it by using the snapshot of this route, and then simply the data object where I can now access message. And of course I have to make sure that this property exists, and we do make sure because we know we can only reach this component through this route where we will have this message property set. So this is the way of using it with its snapshot, or just like with params or query params, if this could possibly change while you still are on this page, you want to use your route and here the data observable to which you subscribe and which will give you this new data object here of type data, some dummy data type you can import from Angular router, which will in the end give you access to your data or the properties you defined there. So here you could then also set it equal to data message. Both would work depending on whether it may change or not. So yeah, both should work. I will comment out the first use case here, but again, if it doesn't change, using the snapshot is absolutely correct or fine. So with this, we should now bind this, and therefore if we save this and go back to our application, enter some invalid route here, we correctly see page not found, the static error message we passed with the data property. And this is a typical use case whenever you have some static data you want to pass to a route. Now let's move on to some dynamic data in the next lecture. In the last lecture, we learned how to pass static data. Now let's say we have some dynamic data we have to fetch before a route can be displayed or can be rendered. For example, here on the servers. Let's say the servers already have been loaded. But once we click a server here, and maybe I should log in to demonstrate this, I want to load the individual server from some backend. So we are going to simulate that this takes a couple of milliseconds or seconds. So how could this work? If we have such a use case, we need a resolver. This also is a service just like can activate or can deactivate, which will allow us to run some code before a route is rendered. Now the difference to can activate is that the resolver will not decide whether this route should be rendered or not, whether the component should be loaded or not. The resolver will always render the component in the end, but it will do some preloading, you could say. It will fetch some data the component will then need later on. Of course, the alternative is to render the component or the target page instantly, and in the onInit method of this page, you could then fetch the data and display some spinner whilst you're doing so. So that is an alternative. But if you want to load it before actually displaying the route, this is how you would add such a resolver. So let's say for the single server here, I will add it in the server file, my server resolver. And again, this will be technically just be a service. So I'll export my class here, which I'll name server resolver. And now this has to implement the resolve interface provided by @Angular router. Resolve is a generic type and it should wrap whichever item or data field you will get here, will fetch here in the end. So we will fetch a server here, and therefore we should define the type here. Now you could outsource this into an interface or a model in general. So we will know that a server will have an ID which is of type number, that it will have a name which is a string, and a status which is a string. So this is simply a type definition of, well, the thing this resolver will give us in the end, to what it will resolve in the end. Now, the resolve interface requires us to implement the resolve method, and this resolve method here now takes two arguments: the route, so the activated route snapshot, which you already know, which you need to import from @Angular core, and it will also provide us the state snapshot, so the router state snapshot, which also needs to be imported from @Angular router. These are the two information pieces the resolve method gets by Angular. And in the end, this then also has to return either an observable, which you need to import from RxJS observable. This observable will then also return this type here. So we can copy this, but since we're creating a lot of overhead here, we can also quickly define an interface here. And it would of course be better to outsource this in its own file, but let's quickly do it here. So the interface for the server, which has an ID of type number, and then the name, which is a string, and the status, which is a string. And now this allows us to simply use server here as a shortcut for this type. So the observable should in the end give us back such a server, or we get a promise, which in the end will return such a server, or, well, just such a server synchronously. So this is what we will get back here in resolve. So now we need to implement the logic to get this back. Now we have our server's service here, and there we have the get server method, which will give us back a server. Now this clearly is some synchronous code. It will run instantly here. So there is nothing wrong with this code. We will resolve this instantly. And as you saw in your resolver, that's fine. One return possibility is to instantly return the data. So the easiest thing we can do here is reach out to our server service. And for this, we need to inject it. So we should provide our server service like this. That's a real hard word for me. Server's service like this. And of course, if you want to inject a service into another service, you have to add injectable to it. Make sure to import this from @Angular core. Also make sure to import your own service. And with this, the easiest way to use this resolve function is to reach out to your service, and there we call get server. And now we need to know the ID of the server we have to fetch, because that is what we do in the server component here in the end, right? There in onInit we're getting this server right now. So now we want to outsource this because let's say we want to do it before it loads. The good thing is we do get the route here. It only is the snapshot, but this service here will actually run on each time we re-render the route. So the snapshot is all we need. Unlike the component itself, again, this is executed each time. So no need to set up an observable or something like that. So here we can access our route, and there are the params, and then the ID, and make sure to cast it with a plus sign in front of it to an integer. This is the easiest way of using this resolver, which will do the loading of our data in advance. And now this would also work if this were to return an observable or a promise, so with asynchronous code, for example, an HTTP request. So this is our resolver. With this resolver in place, we of course now have to add it. So first thing is, in app module, we should add it to our providers, our server resolver, like this. Make sure to also add the import at the top. And with that added now, we want to add it to our routing module. Here, for the route where we want to use it, so let's say for this component here, we add another property, the resolve property. This takes a JavaScript object, and here we map all the resolvers. This is different to the other guards. There we used arrays, but for resolve, a different approach is taken, and you will see why in a second. So here we have key value pairs of the resolvers we want to use. So for the server, and this name of the property is totally up to you, we will use our server resolver. Like this. Make sure to import it here at the top. This will now map the data this resolver gives us back. And remember, it gives us back some data with this resolve method it had to implement. This method will be called by Angular when this route is loaded. So the data it gives us back here will be stored in this server object we will then have available, or in the server property we will have available in this to be loaded component. So in this to be loaded component, in our server component, right now we get the server like this, using the params. Well, I will comment this out, because now we use a resolver for this. That's the goal of the resolver, and it makes even more sense if this is some asynchronous task, of course. So here, we can easily get our server by binding the data observable. So just like static data, which you passed with this data object here, with this data property you could add to a route, the data returned by your resolver will also go into this data baggage, in this data object you have in your to be loaded component. So here we can listen to any changes, and I'm setting up an observable here, or I'm using the observable here, I should say, because the server can change while we already are on the page, as we have this side menu. This is why we also had to set up our route params here dynamically. And here we know we will get back our data of type data as learned before. Make sure to import data from Angular router. And now we know that we can simply assign our server the server property in this component by binding to data server. And now this name here is important. This server here, this name here, of course, has to match the name you use here when you assign your resolver to some property. So if you change the name here, you have to change it when you retrieve the data. Well, with this in place, if we save this with ngserve still running, if we log in and go to servers and we click on a server, you see this still works as intended. It still loads the server like before, but now not using the params here in the server component, but instead using a resolver before this. Again, of course, especially important when using asynchronous data. Almost done. We covered a lot in this module. This has been a very long section in this course, but it has been so important because routing is such a key task in any application. Now, if you have a look at our application, we got a couple of routes in there, /users, /servers, and much more. Now here's one important thing. It works fine here on our local setup, but actually this is not something you should take for granted. If you have a route like this, your domain /servers, and you're hosting this on a real server somewhere in the web, this might not work out of the box, because their routes, the URL, is always, this is how the web works, is always parsed, handled by the server first, so by the server which hosts your application. Now here on the local environment, in our development environment, we're also using a development server, but this server has one special configuration your real life server also has to have. And I will come back to this in the deployment section. The server hosting your Angular single page application has to be configured such that in a case of a 404 error, it returns the index.html file, so the file starting and containing your Angular app. Why? Because as I mentioned, all your URLs are parsed by the server first. So not by Angular, by the server. Now if you have /service here, it will look for a /service route on your server, on the real server hosting your web app. Now chances are you don't have the route here because you only have one file there, index.html, containing your Angular app. And you want Angular to take over and to parse this route, but it will never get a chance if your server, the server hosting your app, decides, no, I don't know that route, here's your 404 error page. Therefore, you need to make sure that in such a case, your web server returns the index.html file. If for some reason you can't get this to work, or you need to support very old browsers which are not able to parse paths like this in the client, which Angular does then, you have an alternative approach to using these nice URLs which look like all URLs in the web. You can fall back to our older technique which was used a couple of years ago, using a hash sign in your routes. Let's see how we enable it, and then I will explain what it does. You can enable it in your app routing module, where you register your routes here with the forRoute method. You can pass a second argument, a JavaScript object, to this method, configuring the setup of your routes. So besides the routes itself, now we can configure them. And one important configuration is the use hash configuration, which you can set to true. The default is false, which is why we didn't have to pass it. If we do this and we save that, let's see what happens. You out of the box see that now we have this hashtag in our URL. And if I click on servers, you see there is this hashtag in between. And that's no bug, that belongs here because this is this hash mode routing. What this hashtag will do is it informs your web server, hey, only care about the part in this URL before this hashtag. So all the part thereafter will be ignored by your web server. Therefore, this will run even on servers which don't return the index.html file in case of 404 errors, because they will only care about the part in front of the hashtag. That's how it works by default. And the part after the hashtag can now be parsed by your client, by Angular. So this is the solution if you can't get the other approach to work. However, I will say that definitely you should try to use the more prettier routes using the HTML history mode, as it is called, with the normal / routes without the hashtag. So this is how you would enable it. I'm going to duplicate this, so to comment this out, to have it there for reference, but I will fall back to the other mode, which gives us cleaner routes, which really look a lot nicer and more like you're used to seeing routes from other web apps. And this is the last piece of this section. Well, we really covered a lot in this section. We learned a lot about routing, setting up routes, setting up child routes, navigating there in code, passing parameters, passing query parameters, extracting parameters dynamically, using guards, using different types of guards, preventing the user from accidentally navigating away, resolving data, passing static data, styling the links which are active, and so much more. This is how you may use the Angular router. We're going to use it in our course project soon, but I can only encourage you to play around with it to really get a feeling for it. And I will also take a closer look at these observables we used in this section so that you feel more comfortable using them too. Let's move on.